אז נתחיל. מי שלא מכיר אותי, שמי עמי דניאלי, אני מחברת מקיט מערכות, המנכ"ל חברת מקיט. אני מניח שכולכם מכירים פחות או יותר את חברת מקיט. אז ככה, קודם כל הוובינר היום מתמקד בנושא שנקרא Low Code Platform for Real Time Application. אנחנו נציג פלטפורמה דינמית, חדשנית של חברת VANTIQ, ליצירה מהירה של אפליקציות דיגיטליות. חברת מקיט מערכות, אני מניח ששמעתם עלינו כאמור, פועלת רבות וידועה במתן פתרונות לשוק התעשייתי בישראל וגם בעולם בתחומים שונים, בפרט ב-PLM, Product Life Cycle Management, מזור חיים של מוצר, מערכות טיבם, גם בתחום של טסטינג, הארדוור וסופטוור, סימולציות ואנליזות מתקדמות וכו'. חברת מקיט רואה ערך רב בפלטפורמה של VANTIQ בפיתוח מהיר של פתרונות באוריינטציה של יישומים עבור מערכות קצה, בפרט מערכות קצה כגון IoT, מצלמות, סנסורים וכיוצא בזה, שמאופיינים באינטראקציה וחיווי במוד של real time. לפיכך חברת מקיט מערכות החלה לייצג את VANTIQ בישראל, למעשה בחודשים האחרונים, במגמה לתת ערך משמעותי נוסף לשוק התעשייתי בישראל. היום בוובינר השתתפו 3 נציגי VANTIQ, אשר יציגו את הטכנולוגיה בדוגמאות יישום של פלטפורמת VANTIQ. הראשון מביניהם זה יהיה ג'יימס אלן, שהוא בעצם אחראי הגלובל טכנולוגי סיילס, וגם כל נושא של Field Enablement Leader. הוא ידבר על כל נושא של Low Code Platform for Real Time Application, וידבר בפרט על הטכנולוגיה הייחודית של חברת VANTIQ למימוש הקונספט. אחר כך אנטוני בראוסה, שהוא אחראי פרטנרים באירופה, וכמובן אנחנו שייכים לאירופה במקרה הזה, ואנחנו עובדים תחתיו, יציג את יישומי VANTIQ ו-use cases בעולם, ונקנח עם הרצאה של סגי זגגי, שהוא גם נציג VANTIQ שממוקם בישראל, ידבר בעברית אני מניח, והוא יציג יישום שפותח בארץ, והוא ירחיב על זה ויציג באמת את הפלטפורמה על בסיס הפיתוח הזה. Now we'll switch to English, so as I told the people here that you are going to present VANTIQ technology and the added value that can give to, especially to the industrial solution. And the first representative from VANTIQ will be James Allen. As I said, he's from the technology sales and field enablement leader. So James, it's your stage now.
Hello, Ami. Can you hear me?
Yes, very well.
Okay. Well, hello everyone, and welcome to the webinar. My name is James Allen, and as Ami said, I'm with VANTIQ. I lead the global effort for VANTIQ to present our technology to the world. Ami, I want to thank you again today for inviting me to present at your program today, along with my colleagues. I now have my screen showing. Can you guys see this? Hopefully you guys can see my screen.
Yeah, we see.
Okay, thank you. Okay, so I do have a lot of material to share, and I'm trying to do it in a very efficient way today. But yeah, my name is James Allen, as Ami said, and I'm a Silicon Valley technology veteran. I've worked at a number of bigger and smaller companies in Silicon Valley, but the last 10, 15 years of my career was spent around Internet of Things, industrial Internet of Things, and these are some of the areas I've worked and the technologies I've worked with. Today, in this short time, I'm going to share with you VANTIQ's perspective on the state of businesses using digital technology to modernize their operations. And then I'm also going to share with you our insights into the kind of technology that's now available to to modernize their business operations, but the challenges in using this technology and how to take advantage of it. And then finally, I will share with you VANTIQ's approach to enabling companies to use the technology to improve their business operations very quickly. That's what I'll be showing you in the next 30 minutes or so, okay? So this first chart shows a number of logos of companies. But the interesting thing is if you look down the middle, on the left side, those are new companies, right? These are companies that are around like Uber, and sorry, most of these are US or European companies, but these were my best examples right now. But other companies on the left side, Uber, DoorDash, Netflix, Amazon, right? And to some extent, Apple. These companies only exist because of the internet. On the right side, these companies, much older companies, Continental, GE Aviation, they make aircraft engines, and the large retailer like Walmart, and also automobile insurance companies like Progressive in the United States, these companies were around before the internet. And the point I'm making here is that internet has made it possible completely to do business online, but you have to be a technology company to do the new things like the Netflix and the Amazon. But what about the older companies? The older companies now, they need to use the internet to survive and to modernize and take advantage of a lot of technology that did not exist when they first started. An example is Continental Tires. Continental Tires now, they're changing their business models. They also sell tires to large fleets of trucks and people who operate large machinery. Continental now, instead of selling you the tire, you actually buy the use of the tire. So they're changing it to as a service model, right? So we're starting to see a pattern that people don't have to own things anymore. They're selling it more as a service. So Continental is now almost like renting the tire to you. But to do that, they have to monitor how much you use the tire, and they're using technology to do that. Same with GE Aviation, right? In the past, most companies, airlines, they will, and aircraft manufacturers, they actually purchase the engine. In a lot of cases, it's actually the airline. They purchase the engine. Well, GE Aviation now, they have a program now where you don't purchase the engine. You pay for the hours you use the engine, okay? And also, they're putting in technology to monitor the engine remotely. So when the aircraft lands, they're taking a lot of telematic data, and they can understand the performance in the engine and predict may there be a maintenance issue or defective part, so they can then fix it before there's a problem. So they're using the technology for remote or predictive maintenance, but also they're using a new model for business where they basically charge by the number of flight hours. Progressive automobile insurance in the United States, changing the model of how they charge for car insurance. Now their customers, they put a device in their car and they can actually monitor how the person drives the car. Are they a very aggressive driver or are they a safer driver according to the analytics? And based on that, they provide a price for the insurance based on the way the person drives, so that not everyone has to be treated the same. Better drivers are rewarded with a better price. And finally, Walmart, a very old and large US company, right? In order to compete with Amazon, Walmart now must have an online experience as well and provide their products and services online. So even Walmart now is adopting digital technology. My point is that all businesses at some point must become a digital technology company and use it, like the new ones on the left, but although the ones that have been around. And finally, Schindler Elevator, a German company that makes elevator systems around the world. They are using digital technology to monitor remotely all the elevator operations around the world, so they can then provide the passengers on the elevators a safer experience and also prevent unplanned downtime, meaning when a system goes down unknowingly. So provides more intelligence for the way they run their operations. So we do see at VANTIQ a shift in the way companies are operating their business because of new technologies, like the Internet of Things and all the things that you can now monitor on the internet, like edge computing. Of course, in the last 15 years, everyone's shifting to the cloud and using cloud computing. Mainly this is for IT organizations or information technology organizations, managing business information. Shifting the applications to the cloud has provided business a lot of enterprise agility. And it's also provided a lot of financial benefits, right? But however, not everything has to be in the cloud. To use some of the new technology for the kind of operational parts of the business we will discuss, and I will share with you, you actually sometimes need to move the computing, the logic of the system closer to the source of the events. We will call them events. More on that later. But also today, you can't really talk about computing without mentioning artificial intelligence. This is now technology that's getting easier and easier to use and easier for people to develop with. So these are the biggest technologies we see today being adopted. And all of these technologies are helping us, right, change from selling a product to providing an outcome. Meaning companies are no longer looking to acquire products so much as they need to have the result. They're trying to do something with the product. So we're really providing what the outcome would be. It's providing a new way of providing services. So instead of owning things, we provide them as a service. And as far as the physical world, it's now possible to monitor your operations in a virtual world, meaning that if you have a facility like an oil facility, you no longer have to drive around to see if there's a problem. You can actually monitor these things remotely using virtual technology. And later on, my colleague Antoine will show you an example of that. And finally, things can now happen in real time, meaning the state of processing with everything networked, with data coming from the Internet of Things. It's possible to actually understand what's happening in your environment, in the operations, and get real-time insights so that you can actually act sooner. So all of these things are driving the way people are transforming their businesses today. And many industries we are working with, all looking to seek what we call better outcomes. And when I say better outcomes, what I mean is a change and improve the way that they are doing business. Some examples here, some of our customers operate very complex environments in real time. Airports, agricultural companies, amusement park or places where there are huge public venues, and of course, industrial companies. And see as some of the common things, they're looking to improve the way they operate and be more efficient. They're looking to improve more safely and with more security, right? They're also trying to be more sustainable and reduce cost and waste and be what we call more green, right? And also to be able to simulate and plan for potential problems in order to avoid them before they happen. So these are some of the top reasons why our customers who are monitoring very complex environments are looking to transform their business. And so here are a few other reasons: responding to situations faster, operating more intelligently, right? Increasing their profitability, but also becoming more competitive or staying relevant, as my example with the Walmart needing to compete with Amazon. And also just being more proactive and not being reactive, meaning anticipate something. You could be anticipating a problem, or you could be anticipating an opportunity, one or the other. Have the intelligence to know so that you can act appropriately to take advantage of the situation. Now, in order to accomplish these types of transformations, right? I am not talking today about IT or information technology. I'm not talking about running a CRM system or an ERP system, right? These are enterprise applications. I'm talking about at the functional part of the company that actually operates the business. And in order to understand and have the insights to be able to make these transformations, you have to have operational insights. our customers are looking for insights into how their operations are running. I looked up the definition of operational intelligence from Wikipedia, and the main points to take is the purpose of having this intelligence is so that you can monitor your business and identify and detect specific situations that may provide you an opportunity to intervene. It could be finding something that's inefficient. It could be finding an opportunity to act, or it could be opportunity to prevent a bad situation. The other part of the definition I found interesting is to use operational intelligence, a lot of companies are using an event-centric approach, meaning detecting when something is happening that's of interest, and then making a decision. And then finally, to make that decision and act, you're going to act on the insights, this information, and you're either going to do it with a human being, or you may use it in an automated way, let the machine do the work. And that's a very important point that we'll come back to in a few minutes. But we have to be able to actually still involve a human being. Not everything can be fully automated, because sometimes you still need the ability for a human to interact and make a decision, a higher level decision. Right? Now, to get these insights, these operational insights, means you must be able to digitally collect these insights. And we now have the technology to collect those insights. Things like artificial intelligence will help us automate some of the decisions, right? IoT, Internet of Things, will allow us to connect things to the network. And edge computing will also allow us to connect things to network, but also allow us to make the decisions faster and closer to the source, so that you don't always have to go to the cloud, okay? So the technology is here. And this technology provides us a lot of source of input, a lot of data. And that data really is allowing us to do a couple different things. One is it's allowing us to track things in space and time. And what I mean by that is that when you can pull information from environments and systems using these new technologies, it's possible now to actually see if something is moving in a space and where, like things in a building or a park or in a plant, a manufacturing plant or a factory. But you can also see things changing the status in time. What's happening? Is it something changing the condition of the thing you're monitoring, right? So these insights will provide us ability to see how things are changing in space and time. The challenge is, how do you make all these things work together? How do you connect all this technology? And of course, it is now possible to run software virtually everywhere. Our microprocessor technology, running ARM processors, low-powered processing chips, anything like that can run software, right? You can make almost everything smart, have the ability to process some type of application or program logic. But be it in the cloud, be it on mobile device or on the edge of the network or as a service, right? You can now run software pretty much everywhere. Also, this technology, there's a lot of new stuff. You have augmented reality, so you can remotely visualize and monitor things and simulate things, right? Autonomous vehicles, connecting things like heavy assets and industrial equipment to the internet with IoT, right? Being able to do recognition, whether you're trying to identify an object or a person, right? This is all logic and devices, a lot of new equipment that needs to be connected to the software. And also, as I said, the ability to also incorporate human being as part of the workflow, because sometimes the machine actually needs help to make the right decision. And of course, we have existing applications that are a source of a lot of data that's needed to add the context to understand the situation. Identifying a person with a camera, a facial camera, is not helpful unless you can connect it back to a system that can actually provide you the information on that individual, for instance, as an example of how these things must work together. So the challenge is, how do you take all this technology and all this logic and you put it all together to work. And of course, do it in real time. And you can see that in the center here, this almost looks like a human brain. And again, more on that later. Now, the challenge is there. And imagine, of course, VANTIQ did not exist when Uber company was founded. Uber was founded before the VANTIQ company that we work at. But imagine to develop an Uber type of application. The Uber application is very much alive, right? It acts in real time. A passenger requests a ride and this discloses a destination. The Uber system matches the driver to the closest location to the passenger that is available, right? So this is initiation, a request, a response. Multiple drivers are notified. Somebody responds. Then we track the passenger, and the passenger tracks the location of the driver, and ultimately they pick up the passenger and delivers them to the destination. This is all happening in real time. It's quite unbelievable today that we can do this in real time. However, imagine how complicated it is to build the application to do this sequence, this logic flow. Imagine how long it takes to build these systems and integrate all the technology, the GPS, the phone application, right? Movement of the cars, the location, the identity of the driver, and integrating it back to the accounts to bill the passenger, right? And also pay the driver. A lot has to happen. Well, these types of applications usually takes many months, years to build. Imagine if you have a platform that you can build these applications in a matter of days or weeks. I said days or weeks. It is possible to do that, and we'll talk more about that later. But here's a few examples, short examples of customers of VANTIQ who are using our technology. They are meeting the challenge, and they are transforming the way they operate their business today. This is a company called WaterBit. They are in California in the United States, and they are a technology provider. What they do is they provide a system to remotely monitor agriculture, the servicing and monitoring how they service the crops, production of crops. They're monitoring the condition of the soil. They're monitoring how much water is flowing to the plants. They're monitoring the equipment that's doing this remotely. And if there's a problem with the equipment, they now can monitor this in the virtual world. They do not have to send someone to drive around and see if there's a problem every day. They can actually at any point be remotely alerted if there's a problem with the equipment. And also, because they're monitoring the soil conditions, they don't overwater. They don't use too much water, and they don't use too little water. So it's also what we call a sustainability application that helps conserve resources like water, improves the cost of agricultural operations, and improves the quality of their yield, their crops, right? So this is an example of an agricultural application using real-time technology with VANTIQ. Another example is a partner we have in China. This is more of an industrial type operation, ENESA. ENESA is hired by the city of Shanghai, China, and there's a law that they have to remotely monitor all elevators in the city of Shanghai. Now that's about 250,000 elevators today. And ENESA has built a system using VANTIQ so they can remotely monitor elevators, and the monitoring helped them prevent a problem from happening before it can happen. It also provides security. They're monitoring what's happening inside and around the elevator. Ultimately, they will be monitoring 250,000 elevators at some point, but today they're monitoring over 7,000 elevators in real time for the city of Shanghai. And they'll be adding elevators at a rate of about 20,000 a year in the next few years. But the business outcomes of this is they're able to help the operators of elevators reduce the cost of insurance. They're reducing the unplanned downtime, so by 50%. And they're also providing much more security coverage because they have security cameras inside and around the elevators to monitor what's happening with the elevators and the people in them. Something a little more urgent today is the COVID virus, the coronavirus. So we have also partnered with companies like Amorph Systems, a VANTIQ partner, a technology partner. Amorph Systems is a company in Germany, and they provide airport operational systems to airports around the world. This is information about the gates, the flights, the passengers, the terminals, right? They're monitoring the airport operations. But with the coronavirus, they've partnered with VANTIQ, and now they've also, together with VANTIQ, we offer a system to monitor people coming off airplanes. We're actually checking the thermal readings and having readings of people's who potentially might have an elevated body temperature, right? So we are now able to help, using this system, airports control the spread of the coronavirus. If someone comes off the plane and we detect they have a elevated body temperature, they potentially might have a coronavirus infection. We now know what flight they came off of. It's possible to know what other passengers were on that flight, where that flight originated. So we can then do what they call contact tracing, trace back where the disease might have been and where they maybe got the infection. But also the airport operations can immediately in real time respond if they see a situation where there's a flight coming in where people may be infected, to have the airport staff dynamically reallocated to move those passengers to a different part of the airport for screening, right? Now, all the examples I just showed you require integrating a lot of new technology, from thermal cameras to mobile display systems, right? To gateways, to location trackers, and so forth. So there's a lot of technology. And again, to put all this technology together, right? Some of it will have to run at the edge of the network because it has to respond locally. It need not go to the cloud to act, because you actually can get all the data running locally on a server inside the company. Some of this information may be in the cloud, right? But you can see how complicated it is to integrate all this technology and make it all work together. The requirements are, it must be a real-time system. The software must be able to run everywhere and anywhere and be integrated into the overall application. Human beings must be able to intervene and so be alerted as part of the workflow. My example with the airport, someone detected with the elevated body temperature, you need to immediately alert someone from the airport operations to intervene, right? Mission critical, meaning the system when running, you must be able to depend on it and it be scalable. So this is really having the right compute resources available to run an application that's an application that cannot go down. And finally, a new requirement these days is you have to build these applications very quickly, right? Incredibly fast development. So then you ask, well, how do we build such applications? What type of architecture do these applications have and where do they run? So this image here is an example of the traditional internet application architecture. This is a typical, and I've generalized quite a bit, but this is a typical architecture for an IT application, meaning applications that are corporate applications, customer relationship management, enterprise resource planning, right? Electronic banking, Amazon, e-commerce, right? Those type of applications, these are IT applications. And generally, there's a human client, there's an internet with an application server to run the application, and a database. This is your traditional, what we call 3-tier architecture: client, server, database. And typically, you're managing business data. These are records, things that can go into a database. You're recording business transactions, right? And generally, we call these synchronous, meaning that there is some type of request from the client, something happens, and then a response comes back, so the client knows it happened, right? So request, response, two-way communication. Generally, these are not real time. Sometimes you make the request, it'll happen overnight, like a banking transaction, for instance. Typically, relatively low volume, not high speed, right? Maybe high volume, but maybe not so high speed. But usually there's a database. because you're recording the transaction, right? Maybe a debit and a credit, maybe a sale, right? Maybe some type of transfer, or maybe you're adding a new employee, right? Or making a transaction like that. So that's the typical characteristics of these applications. The one other point I want to make about this slide, the applications usually running inside the application server. And these applications may have more than one, and they may work together to build a system. These applications, application A might take the order if it's an e-commerce. Application B might do a check of somebody's credit. Application C might check the inventory for the product, but they're all connected somehow. The applications actually call each other. The developers who write the applications have to include code that knows about the other applications, right? So the if this, then call application B, else call application C, for instance, right? Anyway, if you build a new part of the application, like say D over here, and add new functionality to the system, you now must go back and include and modify the existing applications to also include the new app if needed. That's your traditional internet architecture in a very simplified way. But the basic thing is 3-tiered, database-centric, typically enterprise applications. The applications are pretty connected. Okay? But now let's look at if you're dealing with operational insights and the operational part of a business, not the IT side. Well, I'm not the enterprise side, but the what we call the operational side. And they're using this technology, sensors, business systems, IoT devices, and so forth. This is operational technology, right? This is not information technology, it's operational technology. And operational technology is giving us a different kind of data. This data is not records and rows. These are not customer records, right? These are not system records. These are statuses of things, things that are changing in space and time. Things that may be moving or things that may be changing over time. And so it could be the status of a machine. It could be a status of a person. It could be changing location of a vehicle or people. It could be in the environment and sensing an environment. It could be environmental sensors and different kinds of notifications and alerts. And this data is usually high volume, and it needs to come to an application, right? A real-time system. And we call these things events. Events meaning these are things that change in space and time, and when they happen, we say there is an event that happened. And we need to be able to sense that event. Very different than adding a customer or making an order, right? Or doing a banking transaction, very different. And this data, when it comes in, we need to understand the data. We have to have a system that can also add some predictions and make some guesses as to what the data means. Provide us more insight and add context to this data so it's not just data. It's not just events. It's now helping us to determine, is there a situation of interest? What do we mean by situation of interest? This is back when I showed you the operational insight slide earlier. Did something happen that we need to care about? Or is everything normal, right? And so once you determine if there is a situation of interest based on the data, then you must take an action, right? And that action might be if there's a problem with the machine, then the decision might be assign a technician to go fix the machine, for instance, right? So there's something in the middle here that sends the data from the outside world as events, does the analytics or analysis, and this is real-time analytics. And what we're getting from the real-time analytics is what I call the operational insight. This is now using all this technology, bringing in as events, and being able to analyze it for operational insights. And then from that, determine if there's an action we must take in real time. Again, it could be an action to avoid a situation, or it could be an action to take advantage of an opportunity. So with that, if you now think and take these events, can we run these type of applications on the traditional internet architecture? You cannot. That's what the X is there for, because they're not transactional and they are not synchronous. They're one-way communications. They happen in real time, and it does not need a database. So what do you do? What type of application architecture do you need? Well, you almost need a human brain, right? And our platform I'm describing is very much like a digital nervous system, because on one hand, you have inputs from the world coming from this technology. These operational insights come in, and you must be able to sense the data coming in. After you sense it, like a human brain, you think about it. And you determine from your reasoning and from your past knowledge, you add context to it, and then you decide what if you need to act, do something, right? So sense it, think about it, act. You really need like a human brain. And so let me offer you an alternate architecture, right? On the top is the traditional architecture for IT applications. And of course, a lot of companies are using this in the cloud today, the server part. But for operational technologies, to have operational insights and to deal with the kind of event data coming in and also interacting with artificial intelligence systems as well, right? You need a different type of system. This system must be able to sense, analyze, and act on the event data. And we call this an event-driven architecture. At the core of these systems, to be able to act like a human brain and in real time, the modern architecture today to build these applications are called event-driven architectures, or EDA. And they run a lot of times at the edge, meaning you don't have to run these in the cloud. You run it actually together with IT. Sometimes you run it in the cloud. Sometimes you run it at the edge of the network, inside the firewall. If you are an industrial company, you may be running these systems inside the firewall. Okay. At times, though, you may need to connect out to the outside world through the internet to the cloud for certain things. Okay. So I'm going to offer you this, we need an event-driven architecture. But let's take a closer look at what's inside this box. Right? Inside this box is something called an event broker. Sometimes it's known as a message queue, right? But it's really a pipe. Think about it. All the data coming from the events from these systems come in, I call them ones and zeros. If they can come into a high-speed event broker, an event broker is basically something that keeps track of the types of things coming in. The applications in this solution actually talk to the event broker. They are not connected to each other. The application is only connected to this event broker. The event broker keeps track of the types of events coming into the system, and it also keeps track of which applications care, you see. So in this case, applications need not call each other. Matter of fact, the applications don't know about each other. They are separate, in fact. Application each performs a very specific task. Application A may do one thing. Application B does something completely different. Application C does something completely different. So you think about it, they're almost like a service. Each application is like a small service that does a specific thing. Application A might identify the object, an object. Application B might actually provide the facial recognition algorithm for identifying the person. Application C might be the human resource application to identify exactly the name of the person, right? But that's just an example. There are many. However, my point is the applications in this type of architecture need not know about each other. That means that they're only acting and do things when something comes in that they are built to support. Only they're listening to the events that come in through the broker, and the broker just basically is relaying the messages of the different types, and it's using the ledger to know application C cares about A, B, C, D. Application B only cares about these things. So when you do this, you basically have a centralized broker, and in VANTIQ, it's actually not centralized. It's distributed, so it's very scalable. But this broker helps us sense the data coming in, analyze the event to see if there's a situation of interest, and determines if there's the right action to take. So these type of applications are operational data. They are event-centric, meaning we're not getting records and rows. We're getting information about status of things. We may be getting images of things. We may be getting streams of data. They are not transactional. In fact, they are asynchronous, meaning this is one-way input, right? The data comes in. These systems here don't care if you're listening or not, but we're listening. And this is being processed in real time. If you're monitoring an environment or a machine, it could be high volume data coming in. And it doesn't need to be in a database, right? Really, this is just analyzing very quickly. Hey, this happened. Let me think about it. Do I need to do something? No. Proceed. Something else comes in, right? So every little thing that comes in happens. The business logic can be anywhere and everywhere in the different applications, in the sensors themselves, right? So there's all kinds of inputs. It's not just human clients, all kinds of inputs. So the summary here is that there's a lot of advantage to building this high-speed architecture, using this for the modern operational application. You've got what we call loosely coupled applications. They're loosely coupled because the applications are independent of one another, but they only relate to each other through the event broker when there are common events of interest that pertain to the multiple apps. I know I'm giving you a lot of information, and I hope some of that is sinking in and making sense. But this new architecture is what's needed to drive these high-speed operational applications that are bringing in operational insights in a very quick, high-speed way. And because these applications are independent, it's easier to add new applications because the application only needs to listen or publish to this broker. It may be sending something to the broker to inform, or maybe acting on some information to be reacted to, right? So it's very easy with this type of architecture to add new applications and to modify existing ones. If I need to change the functionality of application B, for instance, it does not affect the others because these are all self-contained services. So VANTIQ, our company, realized this need was coming, and we have built a platform that at the heart of our platform is this event-driven type architecture. We do have this event core. And because we recognize multiple years ago that operational technology for operational insights is very different than building IT applications. You need high-speed processing for real time. You need a platform to build these applications very quickly and writing less code. Because when you build these kind of applications, each application is actually smaller. You don't have to build a gigantic application. Each application actually has something very specific. They're all smaller. There's less coding also because our platform provides a way to code less. The application must be distributed because the application logic runs anywhere from the edge, cloud, or even on premises. You have to also build facilities in to build human clients into the system as part of the workflow. But we also recognize you cannot take years or months to build these applications. You need a platform to very quickly enable this and build and change the applications as needed rapidly, right? So our system is often depicted with this diagram that we provide mission critical, meaning a way to actually host and run the applications, that we can run the logic anywhere and easily, automatically put that logic where it needs to be. We include people as part of the workflow and provide high productivity tools to create applications that are over 10 times faster than building them with the traditional methods. Right, and we have tools. We have tools to abstract, because at the heart of when we deploy our applications, they are basically distributed Java code. But without getting too technical, our application platform provides a way to build an application so you really only think about what's happening with the application logic. The developer does not think about deployment. They don't need to think about the network. They don't need to think about if it's in the cloud or an edge. because that decision could be made later when you deploy the application. But we provide a lot of tools to help write less code, model workflows and event models, model the flow like the Uber application, right? And filling in the properties. But behind the scenes, we generate a lot of that code so you don't have to write it. And this actually helps so that developers can actually share this stuff easier. If you ever try to read somebody else's development program code, it takes many hours to figure out, especially if someone leaves the company. Our system is almost self-documenting, because when you go back in to look at these application tools and artifacts, it's easy to go and open it up and see what they did using our workflow, right? We even have tools to develop spatial models and create what we call digital twins of buildings and spaces. So it's actually possible to define a model for a building and every floor and room of the building and track what's happening inside the building, what's moving inside the building. And these are very helpful for security applications, for monitoring assets and their locations, and so forth. So I'm concluding here that VANTIQ, we offer a platform not only for designing the applications, but a single place to develop the applications, after you develop them, to deploy the applications, and then manage them. So we actually combine many technologies into a single platform so that the developers can be far more efficient in creating these applications at high speed. And that is who we are at VANTIQ, is we provide ways to build these applications much quicker, and we're providing a platform. And at this core is an event-driven real-time system. So with that, that's my introduction to VANTIQ. I'm sorry it took a little longer, but I think I'm still left enough time for my colleagues. I think next, hopefully you now have an appreciation of what VANTIQ does and why we're doing it. Next is Antoine will share with you some of our customers and the kind of use cases we're doing with our technology.
Okay. Thank you, James. Antoine speaking. It's me.
Okay, I hear you.
Do you hear me?
Yes, we are. Go ahead.
Okay.
Anton.
Sharing my screen. Hopefully you can see it. Tell me if not. I want to share with you some use cases VANTIQ is addressing. As you can see, is pretty wide as a use cases. We address some smart cities cases, managing buildings, managing a complex situation within a city, which is traffic control, which could be also garbage collections, etc., etc. And I have some example I will comment afterward. Same thing for the fleet management, logistics, which is very related. And I will give you some example on smart manufacturing and safety and security, which is in this period of time pretty sort of pretty strong focus because of our epidemic situation. Here, the first case, which is more a smart city, which is a SoftBank. SoftBank is a big phone and operator in Japan, and they conceived their new building completely connected, which means that if you can see on this picture, there is a train line here, there is a metro line here, and here is the building. What we developed with VANTIQ real time, first of all, security access for the building, which means that any people registered as a visitor previously by his host would be able to pass free within the building because of facial recognition cameras, etc., and will be notified on his phone where he has to go, which elevator he has to use, etc., etc. In case someone which is not registered passed in, then the security will be warned. So they may help the person to go in the right room for visiting the host from SoftBank, or either being pushed out if necessary. On top of this application, which is a complete smart city thing, there is an analysis real time what's happening on the train station or on the metro station. In case there's some issues, delays of trains, etc., contributor from the company will be warned that instead of using the train, they might use the metro with alternatives, and they will be provided with alternative directions. In case of too many people within the rail station, maybe they will receive a notification recommending that they may stay a little more longer, or maybe received an indication of a restaurant they may stay in, waiting for having a better experience using the train. Additionally, which is also smart city application, because of all those cameras the company is using, you may do facial recognition and recognize, for instance, if the person is a male, female, which age, etc., etc. When you go out of the train to go to the building, you are crossing along corridors with a lot of screens for advertisements. The idea here has been to recognize the profile of the person passing by and then adjusting the advertisement depending on the person in front of it. Second application, which is more also smart building, much more technical, it's all about using a digital twin for analyzing the building and providing a proper and efficient maintenance of this building. By using this digital twin, in case of any incident within the building, you are able to send to the maintenance team alerts that they have to change, I don't know, maybe a lamp, maybe there's a leak in some places, but providing at the same time the full plan. For instance, changing a lamp, you need to switch off the power. No, you may warn the people and may inform the people that the switch is in this place. In huge campus, as an airport or any production plants, it can be extremely complex to understand where is the right switch they have to put off before starting to work, etc., etc. So that can bring you real time an extremely efficient way to maintain the buildings. I have some experience with some companies where just changing a lamp may take 2 hours, just because the operator can't find the right switch for taking off the power. So you may save a lot of time, so a lot of money, by using digital twin and real-time notification to the operator. Another big use case for VANTIQ, it's all about logistics. And this is a small example, but this is really all about optimization of traffic, logistic, optimize the way. Here we have real-time port management. You have a boat which arrive with 1,200 container connected. The containers are dispatched into three warehouses. Obviously, we know exactly where they are, and we see that some of the container need refrigerated, I would say, facility. In case, for instance, that we realize that temperature is rising, then we may locate the closest, I would say, truck company or operator for moving the container as fast as possible to the proper location. And then, of course, sending another alert and optimizing the traffic so we may move the container as fast as possible to the final customer. And this kind of thing may be done for very, very different topics. That could be, for instance, for ambulances, where when you have an accident, then the ambulance arrive on site, identify the issue with the person, and may be notified where in the different hospital in the area there is a proper expert doctor, where is free beds, where is the capacity to host the people and treat properly the person. And that would allow us to optimize and to propose the fastest track to treat the person, to take care of the person. So it's all about medical triage, and this is exactly very similar to this kind of things, taking in consideration the local person, real time, being able to be informed about where is availabilities, where I may go the fastest possible, and having the proper care of the item, I would say, either container, either the person. Sorry for this comparison. Another use case, which is a bit more manufacturing, it's obviously maintenance, efficiency, predictive maintenance. And in this case with Fujitsu, they've been able to create a dynamic and automated system where when there is an incident somewhere for Fujitsu devices, then you want the closest, the best trained and the best equipped person for addressing the issue of a customer. They reduce dramatically the time of treatment, I would say, of the incident, and they limited a lot of administration, contact between people, etc., etc. But maintenance in manufacturing is not only it's not the main things. Okay, you need to maintain, and it's all about predictive maintenance, you need to maintain the production line. But you may also think about real-time analysis of the quality of your production. And here I'm thinking about one case we had with a car manufacturer who is doing some pieces of cars with molds. But there are sand molds, and those molds are pretty, you can't use that very long time, and you need to change the mold on a pretty frequent basis. The idea here was to avoid bad pieces and uncompliant pieces. You have this series of molds, and then you need to take offline some of the molds when they are not proper to continue be used. So the idea was, with the sensors and controlling with cameras and laser, the different pieces going out of the line, identifying when you have a bad piece, saying, okay, this piece has been done with this mold, dynamically taking offline this mold and changing it, which is much faster and much efficient than typical control and continuing using the mold or stopping the lines for changing the molds. So this is one idea where you can optimize the lines by controlling quality real time and be extremely fast, so you avoid many pieces and compliance. Another case where real time is extremely important. It's all about video recognition, and human-machine collaboration. In this case, for instance, with cameras, you're able to identify, well, in the case of Corona, people with temperature, people wearing masks and not. In other cases, like in Shanghai, 5,000 cameras watching the different part of the airport are able to identify lost luggages, people falling on the floor for medical reason, or people running or identifying assault supported by AI. And in this case, they reduce the time of security team or medical team to address the event by 3 times. And the idea here was to be faster, more efficient, automatically and dynamically address the issues in a huge facility with an extremely complex system with those 5,000 cameras. Another example here, it's about this company providing heat system, heat for public and private buildings. And the idea has been to dynamically adjust the heat production depending on weather, on the building, depending on the sun, etc., etc. So combining sensors, data from the web, which would be the weather forecast, and adjust the production depending on the local environment, and be extremely precise on what they are producing and how efficient you can be, and wasting the fewest, I would say, heat as much as they could. And finally, one of the last case, Total is one of is the big and the one oil and gas operator in France. They operate all around the world different offshore platforms, refineries, etc., etc. And this initiative, which is called TADI, which is a Total Anomaly Detection Initiative, the idea was to monitor from Paris all the different platforms, identifying leaks, issues, technical issues, etc., etc., to protect the people on the facility. So, for instance, if you have a methane leak in an offshore platform, you may have an issue with human risk, I mean death risk. Because people being breathing this gas. So the idea is from Paris, monitoring everything and being able to act immediately. I will show you just after this one a video which will describe a bit the idea. But it's really warning, of course, detecting anomaly, warning the people around depending on the risk, and acting with drones to solve the issue. So let me show you this short video of TADI, and I will comment on this. Do you see it? So sorry for that, the sound is not working properly, but the idea is really prevent and save lives by controlling incident on different things, on different platforms. So in case you have a leak, whether it's vapor, water vapor, or methane, alert the control center in real time. And then, because of different sensors, of course, you identify where is the leak. You process with database and AI, and you're being able, for instance, in this case, to locate precisely the issue. With all different monitoring systems. And in this case, the system calculates where the gas is spreading from the leak and where are the people, they identified where are the people, taking into account the weather, winds, etc. So they will inform immediately the different people within the area and within the cone where the gas is spreading because of the speed of the wind, etc., and indicate on their phone to each operator where they have to go and being in safe position. In case the weather is changing, VANTIQ is connected to the weather forecast system and immediately will warn the people if they need to change position in case of an issue of this type. Then you may identify with the specific cameras which type of gas is leaking and where's the issue. And finally, because of all those sensors, etc., you know perfectly where you, and supported by a digital twin, you may direct some drones or robots if the zone is too dangerous for people to get in. You will be able to send out dynamically a robot to close, I would say, if there's a leak, to close some faucet around. So you protect and you close the incident by isolating the zone with the risk. And this will be done remotely wherever is the platform, for instance, or the refinery in the world, will be done by one person, a team in Paris directly, instead of having someone taking care of that in every facility. I'm done here. I guess Sagi, you will provide us with a presentation of some cases with the platform itself.
Yes, I will, of course. Do you hear me? Do you see my screen?
We hear you, but don't see your screen yet.
Don't see my screen yet. I'll try to fix it somehow. 1 sec. Hopefully you see it now. Do you see my screen now?
Yes.
Right, so שמי סגי, ואני עובד עם VANTIQ switch to Hebrew, of course. אני עובד עם VANTIQ יותר משנה וחצי בישראל ובעולם. הרבה מהדוגמאות שראינו פה, אני אישית השתתפתי בפיתוח שלהם. ובחודש האחרון פיתחתי מערכת שהיא ממש לפני כניסה לפרודקשן לחברה ישראלית. ורציתי לשתף אתכם בחוויה של העבודה עם הנושא הזה. בגדול, החברה מתעסקת בתחזוקה של מערכות לייצור חשמל. עכשיו זה נשמע נורא פשוט, אבל בסופו של דבר, בכל נקודת קצה, מעורבים מעבר לפאנלים גם המון ציודים, אם זה האינברטר, או שנאים לטובת קרינה, או מנוע שמזיז את הפאנל, מטר שבודק כמה חשמל נוצר. כל הדבר הזה אמור, בכל רכיב יש סיכוי לתקלות, כל הסתרה או כל בעיה יכולה לגרום לירידה בתפוקה, והרעיון של מה שהלקוח רצה זה איך הוא יכול לוודא שהתפוקה באמת לא נפגעת, וכמובן לזהות בזמן בעיות בשביל לגרום לרמת תחזוקתיות גבוהה יותר. היה לזה עוד כמה מטרות משנה שנעבור עליהן עוד מעט, אבל בגדול מערכת מוניטורינג ברמה הזאת. המצב הוא שיש להם המון אתרים בכל מיני מקומות בארץ, והם עובדים מול כמה ספקים. כל ספק יש לו את ה-API שלו, עם הפילוסופיית עבודה שלו. אז הרעיון הכללי של המערכת זה לקרות את הנתונים מכל ספק בתדירות כלשהי, לנרמל אותה לשפה אחידה, ומשם להזרים את הנתונים גם לבסיס נתונים מקומי, לטובת הרצה של לוגיקות, פעם בתדירות ידועה מראש, לטובת זיהוי תקלות, וגם לשלוח את זה לטובת ה-BI לאנליזה ארוכת טווח יותר. תוך כדי יכולות של ניתוח על הדאטה שמגיע ברמת ה-real time או ה-near real time במקרה הזה. אז בשביל לתאר את המטרות של המטרות היו לא רק המטרות הסטנדרטיות של, היי, אני רוצה מערכת מוניטורינג שהיא תייעל אותי, ושהיא תדע לעבוד במרחב הבעיה שלי, מול כמות ספקים, שהיא לא ידועה והיא מתרחבת. השוק הזה מאוד דינמי, כל הזמן יש עוד לקוחות שצריך להתממשק אליהם, ועוד API'ים שצריך להתמודד איתם. אבל אחד הדברים שלא היה להם במערכות הקודמות, כי הם בעצם היה לכל ספק יש את המערכת שלו, אבל מה שלא היה להם, לא היה להם את היכולת לעשות השוואה בין רכיבים ממערכת אחת ומערכת אחרת, שזה גורם להם, ברגע שהם הצליחו לעשות את הדבר הזה, הם גילו תקלות או פתרו אותם, שהם לא ידעו עליהם המון זמן. והנושא של השימוש בוונטיק עם הקולבורציה עם הטכנאי, יש תקלה, בו כבר נשלח לו מידע יותר רלוונטי לטובת הפתרון, יותר איכותי של התקלה. אבל מעבר למטרות הרגילות של האופריישן, לארגון עצמו, היה גם חשוב מאוד היכולת של החבר'ה המקצועיים עצמם, אלה שהם מרכזים את הידע הספציפי, איך הם יכולים לבוא לידי ביטוי בבנייה של המוצר, איך הם יכולים לבוא ולהשפיע אפילו על ידי העבודה עצמית שלהם, באיך שהמערכת מתנהגת. ופה נכנס הנושא מאוד מאוד יפה, מצד אחד הלואו-קוד של ואנטיק, כי החבר'ה למדו להסתכל על הדיאגרמות, ותכתירו למה אני מתכוון, ואפילו לשנות אותם. בעתיד הם אפילו ידעו להוסיף לוגיקות של בדיקה, וכמובן, ואחד התוצרים, אם כבר יש את המידע בצורה מנורמלת, בואו ננסה לשווק אותו ללקוחות, ולהפוך את זה למשהו שהוא מקור הכנסה, וגם זה הם צריכים להיות בעלי היכולת לבוא ולקסטם את הפרזנטיישן של המוצר. מה שיצא מכל הדרישות האלה זה באמת המון דברים שג'יימס הזכיר במצגת שלו, הקודמת. זה הפיתוח הזה הוא ערך בצורה סטנדרטית על ידי 3 אנשים בתקופה של 4 חודשים, ועשיתי את זה ביוני, זאת אומרת, ב5 שבועות עשיתי את הפרויקט, בשלבי בדיקות סופיות. עשיתי אינטגרציה עם 3 מערכות, אחת מהן זה הפריוריטי של הארגון, ו2 מערכות שמספקות נתונים על הציודים השונים במערכת. הוכחנו תוך כדי הפיתוח שאין בעיה לעשות מש דיספליי, בתוך דיספליי של ואנטיק, לפתוח חלון שמראה את ה-ERP של הארגון, בלי צורך בלתת user password, זאת אומרת, חוויית המשתמש היא ממש יכולה להיות פה חזקה ומתאימה למשתמשים לא מנוסים, כמו גם פיתחנו כמה מסכים פשוט שישבו על הוורום, על המסך הגדול, להראות סטטוסים של המערכת. והיופי, מה שהם הרוויחו פה, החבר'ה, מעבר לזה שתוך כדי הפיתוח, הם פתרו תקלות שהם לא ידעו עליהם אפילו חצי שנה, שגרמו להם לתפוקה יותר נמוכה. אם אחד מהם פתאום בא לו איזשהו רעיון של להתממשק לאיזשהו אתר מספק בצורה מדויקת יותר את קרינת השמש באיזושהי נקודה בארץ, עלות האינטגרציה, עלות השינויים פה, היא מאוד מאוד נמוכה. זאת אומרת, התרגיל הזה לא רק הראה שוונטיק במערכות יותר סטנדרטיות, אפילו לא שימוש בחוזקה של וונטיק לטובת אינטגרציה עם AI, גם פה היה שיפור גדול בזמנים של הפיתוח, אבל מעבר לזה, כל השינויים העתידיים, ולבטח יהיו עוד ועוד שינויים, כי החבר'ה מתחילים להבין מה יש להם ביד, גם השינויים האלה יהיה מאוד מאוד זול לעשות, וזה ג'יימס הזכיר את הנושא של ה-deployment wizard שיש במערכת. בעצם התוכניתן כותב את זה בצורה מודוליטית, וכל ההחלטות של מה רץ איפה קוראים בשלב יותר מאוחר. כל ההפרדה הזאת, ה-loosely coupled, גורם לזה שעלויות השינוי הן מאוד 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 נמוכות. אז אם אני רוצה קצת להעיף מבט על המערכת, אז זה למשל המסך הראשי של הפורטל, אז רואים פה את הנתונים המרכזיים של היום, כמה התראות שגילו, ומקום בארץ של ההתראה. אני יכול להגיע למידע יותר ספציפי על התראה, לפי רמת הסייט, כאשר הריבוע הימני, זה בדיוק אותו ריבוע שבו נראה, אם אני הייתי ברשת של הלקוח, הייתי רואה את המידע מהכלי BI שלו, שיושב ב-ERP, ודבר יפה שנוצר פה זה בעצם כלי ניתוח שמאפשר להם לבוא ולשלוף מהרבה אתרים שיש להם, אינברטורים או ברמת הסייט, ולבצע השוואה בין רכיבים שעד עכשיו בכלל הם לא יכלו להשוות, ונותן להם המון כוח ביכולת לבוא ולפתור תקלות, ולהבין האם מערכת עובדת או לא עובדת. מבחינת וונטיק עצמו, כמה שניות על איך שנראה סביבת הפיתוח של וונטיק, זה הוזכר ככה בקצרה, אבל וונטיק נותן מענה לכל שלבי הפיתוח, משלב התכנון עד שלב התמיכה בזמן ריצה. זה לדוגמה המסך שבו ניתן לתאר את דרישות המערכת. מסך שאני יכול לשתף בו לקוחות, וביחד להבין בעצם מה הם רוצים שיקרה. מה הם רוצים, למה אני מקבל דאטה, מה אני אמור לעשות עם הדאטה, ואיזה סוגי לוגיקות אני רוצה להפעיל כחלק מהעיבוד של הדאטה הזה. ויש יכולת לייצר מהדבר הזה בסיס של קוד. אתם רואים פה דוגמה לדיאגרמה שרצה, היא רצה בריל טיים, זאת אומרת, זה הודעות שרצות עכשיו. אני גם יכול לבוא ולראות איזו הודעה רצה. אם יש תקלה, אחד הריבועים פה פשוט יהיה בצבע אדום, דבר שמאוד מאוד יעזור לי להבין איפה התקלה, וכל הכלי תמיכה בנושא של סופורט ברנטיים, אני יכול לקבל את השגיאה, נתונים על השגיאה עם המון מידע שאני לא חוסך לי את הצורך לסמן לעצמי במעבדה, אני פשוט רואה מה הייתה השגיאה ויכול לתקן. עם היכולות deployment המהירות של המערכת, נותן לי מעטפת ביצועית שאני יכול להתבגר מאוד מהר, וכמו באמת שקרה, חבר'ה גילו תקלות תוך כדי הפיתוח. החל מהשבוע השני של הפיתוח, הם כבר התחילו לגלות תקלות אמיתיות, שהם לא היו מודעים אליהם, וזה כמובן חיזק את הכיוון. אני חושב שבשלב זה, עמי, אני מחזיר אליך את הכדור. מיקרופון.
אוקיי, תודה רבה לכולם. Thank you very much for your presentation, guys. אם יש לכם שאלות בעברית, אנגלית, נשמח לשמוע. תגובות, חברים? Any comments? All right. So everything was recorded, so we will publish it later on for other people that couldn't attend this session. We appreciate your time, and we understand that it's very late now in Israel. So again, we appreciate your participation, and of course, we are open for question offlines, and we can talk later about VANTIQ solution. Thank you very much for all of you people, James, Anton, and Sagi, and see you next time.